Alright, today we're going to look at an algebra extension. I'm glad that you joined me for this. And again, make sure that you're taking notes on this so you can use that for your quiz tomorrow. Alright, I'm going to go through this quickly, so pause before I start putting in the blanks so you can kind of see if you can remember what's going on here. And I'll tell you to do that throughout different parts of the video. So make sure you do that now, see if you can remember what's what, and then unpause it. Alright, so parallel lines are lines that have the same slope. Move that to where it belongs. Okay, the lines that have the same slope. Perpendicular lines have the opposite reciprocal. Okay, so those are the two types of slopes. Remember that opposite reciprocal just means that you flip and change the sign. You solve the problems the exact same way as you would parallel lines, but you've got to do that extra step. Alright, so based on this equation that I've left for you here, we want to decide whether these equations down here are parallel, perpendicular, or neither. Now pause the video, answer it yourself, and then unpause it for the answers. Alright, so for the answers here, I want the slope of the lines that are parallel. So I need a slope of a positive 3, so that would be that one. And it doesn't look like I've got any other ones. So for perpendicular, I want to flip it and change the sign. So I need a negative 1/3 for my perpendicular. There's one. There's another. Let's see what I've got left. Negative 3. That hasn't been flipped, so those two lines intersect, but not perpendicularly. 1/3. It's got the reciprocal, but it's still the same sign. And then I just have y equals 3. We just got ourselves a horizontal line there. So check your answers, and there we go with that one. All right, so we're going to look at two examples, and then that'll be it for this video. Okay. All right, so we want to write an equation of a line that's parallel to that line and passes through that point. Remember, we have two equations that we can use to solve this. We could use that point slope form, so y equals mx plus b, or we could use, slope intercept form, or we could use point slope form, which is y minus y1 equals m times x minus x1. Okay. All right, so I can use either one of those two. In this problem, since I've been given a point, and I know the slope of a line that's going to be parallel, I want to use point slope formula. Significantly easier. Alright, so we're going to go ahead and answer what we've got. So I know my y1, it's 1. So my equation is going to be y minus 1 equals my slope. It's parallel, so I want the same slope. So 1/2 times my x minus x1, so x minus 6. And that's your equation. That's your equation in point slope form. And you're done. That's it. Okay. All right, next example. This is one that you probably have not ever done anything like this before, so make sure you're paying attention to this. So it says it's giving me 2 points, EF and Q. Okay, so I've got 3 points there. I want 2 possible locations for point P so that EF is parallel to PQ. Okay, so let's look at what we're going to do here. I want it to be parallel, so I need to find the slope of EF. So the first thing I'll do is find that slope. So for line EF, remember, it's going to be your y1 minus y2 minus y1 equals x2 minus x1. So my y's, so I'm going to have negative 4 minus 0 over my x's, 5 minus negative 3. I'll simplify that. Negative 4 minus 0 is negative 4. My x's, 5 minus negative 3 is 8. We'll go ahead and reduce that to negative 1/2. So that's the slope of EF. I want to find the slope of PQ. I don't know P, but I can work backwards to find it. I do know Q, so my formula for PQ, remember your point slope formula, your slope formula looks like this, y2 minus y1 over x2 minus x1. Okay, so I know what my y2 and my x2 are. That's Q. I'm looking for my x1, y1. So I'm going to go and plug in the values that I know. So I have 2 minus y1 over 4 minus x2. And so what I'm going to do is I'm going to set that equal to my slope, negative 1/2, because it's parallel, so I want it to be the same slope. Now, I can look at this as two separate things. I've got a fraction here, so I can look at my equation on top, and I can look at what I have on bottom as a completely separate equation and go ahead and solve it that way. So that's what I'm going to go ahead and do. So I've got 2 minus y1 equals negative 1. I'm going to solve for y there. So I'm going to subtract 2 from both sides. So I get negative y equals negative 3. So then my y equals 3. I'm going to do the same thing for my x. So 4 minus x equals 2. I'll subtract 4 from both sides. So I have negative x equals negative 2. So my x is 2. So that's one of my ordered pairs, which is going to be 2, 3. Okay? But it wants 2 of them, so I got to do one more. One thing that I can do is I can just apply my slope. That's another way. So I solved finding algebraically. Now I'm going to solve it just kind of reasoning through it to find these other ones. Okay, so I've got this negative 1. So I'm going to, that negative 1 is for my y value. So I'm going to go down 1, which is 2. The 2 is positive, so I'm going to go to the right 2, so 4, 2. Well, that's cute, so I'm not worried about that one. I'm going to go ahead and apply that slope one more time. So I'm going to go down 1 to make that 1. And then my 2, I'm going to the right, so it was 4. So now that plus 2 is 6. Don't forget my parentheses. And there would be my other ordered pair. Okay, so there's 2 ways to get those 2 values. You could either solve it algebraically, or you could just apply that slope. That's it for the video.